Let's talk about how LLM-powered apps are usually built, because the way you design your system has a huge impact on how secure it is. There is no one perfect architecture for LLM apps, but a few patterns are becoming pretty common across the industry. One of the most popular right now is called Retrieval Augmented Generation, or RAG. Let's start there. Let's break down what RAG actually is. RAG is a design approach where your model pulls in fresh data at runtime. Instead of answering questions only from what it memorized during training, the model actively retrieves documents from a custom knowledge base or a vector store and uses that fresh information to generate better, more relevant responses. The typical flow looks like this. The user asks a question, the system turns that into a search query, it retrieves the most relevant documents, feeds those documents into the model's context, and then the LLM generates a final answer. This setup is super useful for domain-specific applications like legal research, financial advising, customer support, or internal company tools. But like everything powerful, it comes with trade-offs. Here's the security catch with RAG. Every single part of that pipeline is now a potential attack surface. Think about it. User input could carry hidden prompt injections, the retrieval layer might pull the wrong or even malicious data, the retrieved content itself could be poisoned, and finally the LLM might echo or transform that unsafe content into something dangerous. Instead of securing just the model, you now have to secure the entire flow from input to search to generation. Let's take a specific example. Imagine your knowledge base includes articles that users can upload. If someone sneaks in poisoned content, text designed to trick the model in subtle ways, your system might end up spreading misinformation or leaking sensitive data without even realizing it. This type of attack is called indirect prompt injection, and it's much harder to spot than you think. Also, think about the vector database itself. If it's exposed or not properly locked down, an attacker might do some real damage. They could steal private vectors, inject malicious ones, or infer what kinds of queries users are making based on access patterns. That's why access controls, encryption, and active monitoring are absolutely critical at the vector storage layer. And RAG isn't the only architecture with hidden risks. Let's look at a few others you might come across. Some teams fine-tune a base model using their own internal data. It sounds like a smart move, and it can be, but it comes with its own risks. If the training data is poisoned, even slightly, it can introduce hidden backdoors into the model. Fine-tuning without proper controls can also cause overfitting, leading the model to memorize and leak private data when prompted in just the right way. The bottom line: sanitize, verify, and audit your fine-tuning data every single time, no exceptions. Then there's agentic systems. This is where LLMs start not just responding to prompts, but actually taking actions. We're talking about systems where the model can browse the web, call APIs, write to files, or even trigger automated workflows. And if you're not careful, these agents can go completely off the rails. Real-world examples: agents that accidentally deleted critical data, bots that flooded external services with junk requests, even agents that chained dangerous commands together with no human review. The key here is simple: strict sandboxing, tight permissions, and a human in the loop for anything that matters. Never give an agent more power than it absolutely needs. Another common design is plugin-based LLMs, where models are extended using modular plugins like database query tools, calculators, or custom APIs. It's a powerful way to extend functionality. But every plugin is essentially another open door into your system. If attackers can trick the model into calling a plugin incorrectly, it could lead to serious problems in your backend systems. The best approach? Treat plugins exactly like third-party dependencies. Secure them, monitor them, and don't give them more access than they absolutely need. So, how do you stay ahead of all these risks? You do what good software engineers have always done. You apply threat modeling. You ask the tough questions. What are the inputs? Who controls them? What trust assumptions are we making? What could go wrong at each step? You map out your entire architecture. You draw the trust boundaries, and you simulate attack scenarios before real attackers have a chance to find them. Here's the takeaway. The way you architect your LMM app shapes your security posture from the very beginning. More complexity means more risk, but smart design, tight isolation, and proactive guardrails can turn that risk into resilience. Coming up next, we'll dive into the threat landscape itself, who's attacking LLMs, why they're doing it, and what they hope to gain. Stay with me.